Today we're going to talk about, basically we're going to define the atom and then look at some properties and subatomic particles. Okay, so matter is composed of atoms, and then the most fundamental different types of matter, we call those elements. There are, 118, but I'm pretty sure they just have more than that now, and they're continuing to try to discover new elements. We're going to talk about isotopes and ions and what we mean by that. Okay, so let's jump into it. So, first thing, what makes an element unique from other elements is it's positively charged. That's found in the nucleus of the atoms. So the atomic number is the number of protons found in that atom. So when I look at my atomic number here for hydrogen, there's one proton found in the nucleus of a hydrogen atom. So that means if our atomic number is different for every single element, that means the number of protons is different for every single element. Now, remember when we talked about this idea that matter is neutral and protons are positive and electrons are negative? So in order to have a neutral atom, we have to have the same number of protons as electrons. Okay, so my net charge, I want it to be 0, and so the number of positive protons added to the number of negative electrons should give us a 0 charge overall. So if I'm looking at helium, helium has an atomic number of 2, and so we have 2 protons in our nucleus here, and then we have 2 neutrons, and it has 2 electrons. Now, neutrons aren't always equal to the number of protons and electrons. So let's focus on, we have 2 protons, positive protons, and so then we have to have 2 negative electrons to cancel that positive charge. So again, just a reminder, atomic number is the number of protons in the atoms of those elements, and that's unique, meaning there's no 2 elements that have the same number of protons in the nucleus. Okay, so we have some concept check ideas. So I'd like you to hit pause and go through this and then come back and see how you did. All right, so we have number 1, atoms are made up of 3 subatomic particles, that would be protons, neutrons, and electrons. Number 2, where each of the subatomic particles located. Protons and neutrons are in the nucleus, electrons are outside of the nucleus. 3, where is most of the atom's mass found? In the nucleus. 4, what are the relative charges of the following? Well, proton is positive, neutron is neutral, 0 charge, and electrons are negative. And so then what I would want you to do is go to a periodic table, and you're going to find radon, and you're going to find magnesium, and their atomic number will tell you the number of protons. Okay, and then we have the similar idea here that an atom of an element contains 66 electrons, and so that means it has 66 protons, which again is the atomic number. So find the element that has an atomic number of 66, and that's the element that we're working with there. Same idea with number 7, but we have 14. Okay. Now let's see what we have. I'm going to skip this table. Okay. Who proposed the first modern atomic model and suggested the elements combine in definite proportions? That was Dalton. Who discovered the electron? That was Thomson. Who discovered the nucleus and the protons? That was Rutherford. Atoms are mostly empty space. All particles in the nucleus of an atom are charged, though that would be false, right? Because neutrons are in the nucleus and they are neutral. The atom is best described as a uniform sphere of matter in which electrons are embedded. that would be false. That's not the best description. That was a description at one point, but now we have a better electron cloud model description. C, the mass of the nucleus is only a very small fraction of the mass of the entire atom. That'd be false. The nucleus is the majority of the mass of the atom. D, the volume of the nucleus is only a very small fraction of the total volume of the atom. See, that one is true, because remember, atoms are mostly empty space, and even though the nucleus contains most of the mass, it's only a tiny fraction of volume where all that mass is found. And then E, the number of neutrons in a neutral atom must equal the number of electrons. That's false. The number of protons needs to equal the number of electrons in a neutral atom. All right, so here's one way in which atoms can differ, and that is the number of neutrons. Okay, and so we can have two atoms of the same element. Like, let's say we looked at helium before, so we have two atoms of helium, but one of those atoms only contains one neutron and the other one contains two neutrons. Those would be isotopes. They're the same element because they have the same number of protons, but they're isotopes of one another because they have different number of neutrons. Okay. Now, the more neutrons an atom has, the more mass that it has. So back to our helium with two neutrons, that would have a greater mass than our atom with one neutron. Now, for the sake of in this moment of this class, we're going to recognize that different elements have different chemical properties, and what makes them a different element is their number of protons, but it is in fact the difference in electrons that changes their chemical nature, but we'll talk more about that later. All right. Okay, so we have these oxygen isotopes. So we have 8 protons in each of them because that's what makes them oxygen. Okay, and we have 1, 2, 3, 4, 5, 6, 7, 8 electrons in each of them. That's what makes them neutral. And so what is the same for each of these isotopes? Well, the number of protons and the number of electrons are the same. What is different in each isotope? The number of neutrons is different. We have 8 neutrons, 9 neutrons, and 10 neutrons. So that's the difference. So a little addition question here. Which of these 3 would have the highest mass? Well, that would be our third isotope there because we have the most neutrons. So back to this idea of mass. We also know that our elements have a mass number as well as atomic numbers. Like there's a mass number. The mass number is the number of protons plus the number of neutrons. Okay, so if I come back here, I have 8 protons and 10 neutrons, and so my mass number for this one would be 18. And my mass number for this one would be 17, and then my mass number of this one would be 16. This is the number of protons plus the number of neutrons. Okay, so when I look at my different lithium atoms that I have here, the element symbol is Li for all of them. The atomic number is 3. You have 3 protons, that's what makes them lithium. The mass number is different though. This one has mass of 6, then mass of 7, mass number of 8. Okay. Now, if we know that our mass number is the number of protons plus the number of neutrons, we can figure out how many neutrons we have by minusing the number of protons. We can take mass number minus my number of protons, and that will tell me my neutrons. So I can take my mass number of 6 minus my atomic number of 3, and so I have 3 neutrons. And then I'd have 4 neutrons, and then I'd have 5 neutrons. Okay, so we're going to circle the mass number of each of the isotopes of carbon. So circle those. We're going to put a square around the atomic number. How many protons are there in each isotope? Well, there's 6 because that's the atomic for both. How many neutrons? Let's see. Well, 12 minus 6. So the first one has 6, and then the other one has 14 minus 6. So that would be 8 neutrons. Okay. How many electrons? Well, they're neutral, and we have 6 protons, so each of them have 6 electrons. Okay, give this concept check review on the go. So hit pause and do that, and then we're going to continue when you get back. All right. So, finding the atomic mass on our periodic table. So we're given this atomic mass number on the periodic table, but recognize that's not a whole number. So how could that possibly be the number of protons plus the number of neutrons? And here's what's going on here. You know how elements can have more than one isotope, meaning they can have different masses because they have different neutrons? We need to take all of those isotopes into consideration when we say the mass number of the element. And so what we have to do is we have to take a weighted average to get our mass number. And we're going to learn how to calculate a weighted average. Okay, so that's why it's not, the atomic mass is not a whole number. It's because it's a weighted average of all the different isotopes. Now the individual isotopes themselves, they will have, the individual isotopes themselves will have a mass number that's always whole numbers. But when we're looking at the weighted average of all of them, it's likely to not be a whole number. Okay. So here is how you find the most common or the most abundant isotope of an element. Okay. So like we're going to look at carbon, oxygen, and sodium. And I'm going to have to kind of make this smaller, and we're going to pull up a periodic table. Okay. All right, so let's see what we have here. All right, so the first one that we had in our notes was carbon, and we want to know the atomic mass. So carbon has an atomic mass of 12.009, and then oxygen has an atomic mass of 15.999, and sodium over here has an atomic mass of 22.990. Okay, so those are my atomic masses. Now I want to know the mass number of the most common or abundant isotope. And so what you do is you take the atomic mass from the periodic table and you round it to the closest whole number. So for the most common isotope of carbon, it has a mass number of 12. And for the most abundant isotope of oxygen, it has a mass number of 16. And then the most abundant isotope of sodium has a mass number of 23. Okay? So the second video for today's material is we're just going to go through and we're going to calculate weighted averages of these isotopes to figure out that atomic element mass.